So now we're going to use the principle of completing the square to solve any quadratic equation. Okay. Now we're going to get a formula. I should emphasize that the first thing you should try is solving by factoring. Okay. If that fails, then you can apply the formula we're going to obtain here, which is called the quadratic formula. So to obtain that formula, so I've got a here that multiplies x squared, so I'm going to factor that out. So it's the same principle as, you know, when we had something like this. To complete the square, we first factor out the 2, okay? And then we complete the square inside here, okay? So same idea here. We're going to take out the a. Okay. And, oh, actually, you know what? It might be easier just to get rid of the c first. Okay, so let's backtrack a little bit. I'm going to just send c on the other side first. I think it's going to make our life a bit easier, like this. And then we're going to complete the square of what I have on the other side here. Okay, and I take out the a, like this. All right. And now I'm going to want to add something to make the first 3 terms a perfect square. Now, b over a, that's kind of like our previous b, like I'll write capital B, okay? So what I want here is, I want to take b divided by 2 and square it, okay? So that's going to give us b over 2a. Okay, so b over a divided by 2 is b over 2a. I square it, and now the first 3 terms, so I can even start writing down the next line. It's going to be, the first 3 terms are equal to x plus b over 2a squared. Okay, but of course, if I add b over 2a squared, I need to subtract it. So I'm going to do that immediately. b over 2a squared is subtracted, so everything stays equal. So just here, I'm just going to expand it now. b over 2a squared is, that's b squared over 4a squared. Okay. And essentially what I would like is just to solve for this. I'd like to have like this squared equals to some number, and then I'm going to take the square root on both sides, do plus or minus square root and solve for x. Okay, so this is what I'm aiming for. So I'm going to solve for this expression here. Okay, so first of all, I'm going to get rid of this guy here, or maybe just expand everything. Maybe that's some simpler way of saying it. I'm going to multiply by a, everything. So as I multiply this by this, you see I've got a at the top and at the bottom. They're going to simplify. So I'm going to keep the b squared, the 4, but a over a squared just becomes 4. 4a. Okay, and this is equal to minus c. So I'm going to send this, the b squared over 4 on the other side. Like this. And I'm going to divide everything by a to get rid of the a that multiplies my perfect squared. So x plus b over 2a squared is, okay, divide everything by a now. So this is minus c over a plus b squared over 4a squared. So what I have on the left hand side is some number, right? A, b, and c, they're fixed, right? So when you're given an equation, I don't know, 3x squared plus 4x plus 5 equals 0, you see a, b, and c, they're given to you, okay? So there's no x here, okay? It's just a number. This is just a number. So it's a sum of 2 fractions. So just to make it look nicer, I'm going to write that fraction, that sum of fractions over a common denominator, and add up and write it as a single fraction. So the common denominator would be 4a squared. If I do this, I need to multiply the c by 4a, and like that. Okay. Okay, and usually we actually write it in the as b squared over 4ac. So So this is usually how you're going to see the formula written down. So right now I've got my perfect squared equal to a number. So this is where I'm going to solve by taking square roots on both sides. So I'm going to get plus or minus the square root of b squared minus 4ac over 4a squared. And then in here, this expression I have here, this square root, I can simplify it. Okay, so I'm going to use the fact that if I have a over b square rooted, it's square root of a over square root of b. So that's because, why am I using this? It's because the 4a squared is a perfect squared. So I'm going to be able to essentially simplify the square root of the denominator. So this is plus or minus square root of b squared minus 4ac. There's nothing I can do with that. It's the square root of a difference. So there's no chance that I can simplify this. And don't you dare write this as b minus square root of 4ac, right? That you can't do that. Like the square root of a difference is not the difference of the square roots. Okay, you can only sort of this there's this property that's true, and this one that I wrote down, that's true. Like the square root of a product or a difference can be written differently, but if you've got a square root of a difference or a sum, okay, that's it. You're gonna have to factor what's inside if you want to simplify it, but you won't do that here. And at the bottom, I've got the square root of 4a squared. So that's going to be, well, so that stays what it is. So maybe plus or minus again. And at the bottom, square root of 4. So here I'm going to apply the principle of the square root of a times b is square root of a times square root of b. Okay, so square root of 4 is 2. And square root of a squared, technically square root of a squared is absolute value of a. But I'm going to write a for a reason. If a turns out to be a negative number, okay, well, that's not going to be a. It's going to be the opposite of that, of a. So if a is I don't know, is minus 3, the square root of minus 3 squared is not minus 3. It's going to be 3. So that could be actually plus or minus a here. But since I already have a plus or minus at the top, plus or minus times plus or minus, that's still plus or minus. So you can safely replace the square root of a squared by a. Okay, so I've got this is equal to this. So the final step is just to solve for x. So solving for x, I just subtract minus b over 2a here. And everything's over 2a. It's kind of cute. So usually we write that down as minus b plus or minus root of b squared minus 4ac over 2a. And that's our quadratic formula. We get basically two roots. So either you have, usually if you've got x is minus b plus the square root of b squared minus 4ac over 2a. Or you've got x is minus b squared minus 4ac over 2a. So you have possibly two roots for two solutions for your quadratic equation. Now there are cases where you could have like just one solution. That would be the case where b squared minus 4ac, which is called the discriminant. So if that expression here, b squared minus 4ac, maybe let's not frame it, I'm gonna highlight it. If that's equal to 0, you're going to be having plus or minus 0, so it's not going to change anything. So it's as if you could completely erase this part. So x would be minus b over 2a. So that's in the case where b squared minus 4ac turns out to be 0. So possibly one solution in that situation, and possibly no solutions also if b squared minus 4ac is a negative, because you'd be taking the square root of a negative, in which case there are no x that satisfy the equation. So I'm going to show you the formula in action. But actually I took a problem from the book that shows you actually something I that I want to emphasize. I'm going to show you solution number 1. Solution number 1 should be always try to factor it using factoring techniques. And actually, this is one you can actually solve using factoring techniques. So you wouldn't need the quadratic formula. But I'm going to do it with the quadratic formula afterwards to show you that the formula does indeed work. So solution number 1 would be the one you'd actually use here. So, you know, product of minus 18, sum of 9. What are the two numbers? What did I say? Sum of 9 is sum of 3. 6 and minus 3, which are going to work. So I'm going to split my middle term. Here we go. You factor by grouping. And you get this. Okay. And now I get two solutions. One is by equating the 3x minus 1 to 0, in which case you get x is 1/3. Or you get another solution by equating 3x plus 2 to 0, in which case you get minus 2/3. So let's apply the quadratic formula to see if that would have worked using the formula. So here, you know, in the formula, a is going to be 9, b is going to be 3, and c, make sure to incorporate, right, the signs, right? So you need to think of this as 9x squared plus 3x plus minus 2, right? So same goes if this would have been minus 3x. Well, minus 3 b turns out to be minus 3. Okay, so you need to watch out for the signs of a, b, and c. So x is, according to the quadratic formula, minus b plus or minus square root of b squared, so 9. Actually, let me do this slowly. B squared minus 4 times a times c. All that divided by 2a. So this is minus 3 plus or minus square root of 9. Minus 4 times 9 is minus 36 times minus 2 plus 72 over 18. 9 plus 72 is 81, which is a perfect square. So here we're going to get rational numbers for the solutions because what's underneath the square root is a perfect square. So plus or minus 9 over 18. So then we get two solutions here. X is either minus 3 plus 9 over 18, which gives us what, 6 over 18, so 1/3, which is this solution that we got previously, right? 1/3. We should be getting minus 2/3 with the other possibility, which is x is minus 3 minus 9 over 18. So that's minus 12 over 18, which is indeed minus 2/3. So yeah, they are identical. Okay. Moral of the story, if solution number 1 fails, if you cannot find a sum, a product, values for P and Q, such that the sum and the product, so finding the two numbers is impossible or difficult, you can switch to solution number 2, which uses a quadratic formula. And then looking at what you see underneath the square root will tell you how many solutions you have. So if this turns out to be a negative number, you have no solutions. If it turns out to be 0, you're going to have a single solution. And if it's which is the case here, it turns out to be a positive number, you're going to have two solutions.